storage. Our three organizations got to know each other during EUW 2019, so European Utility Week 2019 last year. And today we are following our cooperation with the first webinar. But others will be organized in 2021. And finally, we hope that at the occasion of Energy Mission, which is an international conference in Flanders in October 2021, we will like to bring all the interested parties together in real life. And perhaps after that, we will also meet again in France so that everyone can visit some of our projects in Bretagne and Pays de la Loire. And Valérie, I leave you the floor.
Yeah, hello everybody. I'm Valérie Graven. I also work for Smile. I'm a Smile showroom manager in Rennes. And during the next 90 minutes, all parties will give a state of play of storage project in their region. But before we start, please just turn off your microphone if you're not a speaker, and feel free to write down your question in the chat room. So this webinar will be recorded, and we will be able to send you the PowerPoint and the recording afterwards.
So as you have noticed, we are three organizations today, Smile, Flux 50 and Tweed, and we will each introduce you some of our projects about storage, but we will start with Smile. So Smile means Smart Ideas to Link Energies, and we will just give you a small introduction of, I've lost my... of what is Smile, and then we will introduce our two speakers for today. So Smile, sorry Valérie.
It's not the right screen you share.
Ah bon?
On voit pas ta présentation, Marine. Là, on voit une page YouTube.
It's not my screen actually. I don't know. Someone is sharing his golf screen. Interesting.
Who is sharing his screen?
Someone has taken the, I don't know, Giola Jacopo, obviously.
Yeah, but it's the name Jacopo Gioia.
Yeah. Which is not my name.
Okay.
It's okay. I do it. I think it's fine now. Yeah.
Yes, it's better now.
Sorry, I don't know. Please just don't share your screen. So as I said previously, Smile, it's an organization. It's a collaborative program between two regions in Western France, Bretagne and Pays de la Loire, and our goal is to support the emergence, the implementation, and the deployment of collaborative projects in smart grids and energy management to ensure energy transition and sustainable growth. As you can see on the slide today, we have more than 300 stakeholders, so companies, public authorities, clusters, research centers, NGO, and even much more. And on our 300 members, 70% of them are private companies. And we've also created a showroom. So we have two entrances, one in Rennes that Valérie is managing, and the other one in Nantes that I am managing, in charge of. And in these places, we welcome national and international delegations to show them the innovative solutions we are deploying and our companies are deploying in Western France to address energy transition. So we will be really pleased to welcome you when the situation will be okay. And finally, 89 projects are now certified Smile, and they are all collaborative projects involving many partners and tackling one of the following topics you can see on these screens.
Okay. Some of these 89 projects focus on storage with different perspectives. First, self-consumption. Energy storage can help to increase the rate of self-production of electricity. Second, convert renewable electricity in hydrogen. Hydrogen can later be used for mobility or other stationary application. It refers to SMILE projects like San Joaquin or H2X. Then the use of electric vehicle batteries to store electricity. It refers to SMILE projects such as Drop and Plug. It allows services like vehicle to grid or vehicle to home. Also, storage of renewable electricity as a tool to sell electricity on the marketplace at a better price. It refers to Sipango SMILE projects, for example. Then energy storage on non-connected islands in order to become autonomous using only renewable energy. Refer to Western Saint or Molen Island SMILE project, for example. Also storage to be used as a backup for electricity network and provide energy when needed. Refer to plug-in stockage SMILE project. And lastly, storage of energy produced through an industrial process to be used later for the process itself in a virtuous cycle. So there are various means to store energy. Battery storage is the most common process, but hydrogen, as mentioned earlier, is also used. But also heat, refer to Stolect or Symbiose SMILE project, and also methane, for example, the West Grid Energy project. You can find more information regarding all the projects I have mentioned on SMILE website, smilesmartgrids.com.
But after this short introduction we've made about SMILE, please, if you have any questions, feel free to send us email or ask them in the chat. We will now leave the floor to Philippe Jakubowski, who's going to introduce his project called Réseau, which is a SMILE project. Please, Philippe, go ahead. Philippe, are you with us?
Your microphone is still
Sorry,
off.
I forgot my microphone. Hello, everybody. So thanks for giving me the opportunity to present you the project Récuperation. So if you can move to next slide. Okay, so the project is a combination of two small projects. So first, in our factory at E4V, we have launched a project called Recuperation, which is a recovery of fatal energy from battery manufacturing. What is happening actually, it's upon final testing. We are a battery pack manufacturer, so at the end of the manufacturing, we have a test whereby we charge completely the battery at 100%, and then we discharge the battery to check that the battery is offering the proper energy storage. And we check also during this process a couple of technical parameters. So up to now, the energy which was discharged from the battery was dissipated in a form of heat. So it was not very interesting. And so now what we want to do with Recuperec, it's to have a reinjection of the energy into the factory network. So it will be self-consumption for the factory, and what is produced in Exceed will be stored in storage batteries. So on the other side, we have a Réseau, which is which provides some services to the grid with a battery buffer, typically 1 megawatt. And the target is to make a primary reserve. So what we have during this what has been taken, it's what the frequency is too low. The buffer gives energy to the grid. And when the frequency is too high, the buffer takes energy from the grid. So this is a rather smooth process without any high power. And what we are doing, so the main purpose of the megawatt hour is when there is a major failure in a power plant or in the network. In order to prevent a blackout of the network, the battery buffer has to provide high power during about a quarter an hour. And the purpose is to let a backup plant to start. And typically it's a turbine or a coal plant. And in France, so this is the way it is done in France. So the purpose of the project is that the battery buffer and all the conversion, the transformer, all the civil works required by this infrastructure is quite expensive. And we observe that the daily use is frequency control, which use about 20% of the battery capability. So it's a bit like going with a sport car on a small road. And the grid backup is quite an exceptional event. It might happen once, or perhaps if it is a bad year like 2020, twice a year. So we think that there is a waste of resources which are installed but not really used. So what is the purpose of Recuperation is to use the batteries for other purpose. So part of the battery buffer is used for grid services to provide to offer the daily use of frequency control. And the rest of the battery buffer is used for energy recovery in E4V factory. So this is the project we have labelized with SMILE. And so if we look more into detail of the implementation, so the Recuperation side consists of setting some converter to load the battery under testing. And these converters are taking the energy from the battery under test and put it in a battery storage. So this is the green arrow we have on the top screen. And when it is needed, the battery storage give back the energy to the local network of the factory, local electrical network. So it is used then to supply the factory and to compensate what we are consuming from the grid. And regarding the réseau side, so what we have one or two containers which are used for the battery storage and the conversion. So the containers are installed at the battery factory, at the E4V factory, and they are connected to the grid through a high voltage connection. And when the battery, when the container requires some support from the factory, when we have committing a switch which takes the battery from the factory and connects them to the network of the containers. So this is what we are going to implement. So a few words about E4V. So basically, we are a battery manufacturer, and we are using LFP lithium iron phosphate technology since 2008. So we believe it's a good technology because it's green. Inside the battery, we just have iron and phosphate. So iron, it's well known. It's used everywhere. We know how to recycle iron, and phosphate is also quite available in the ground, and it is used also as a fertilizer in agriculture. So far we have developed more than 25,000 vehicles. So most of them are special and professional vehicles, and they are used everywhere, and I think in Belgium as well. We are also making some small cars, like license-free cars, and typically, I don't know how it is known in Europe, but Citroën, which is part of PSA Group, has developed a new small car, electric car, AMI, and we are manufacturing the battery for this program. Regarding stationary application, we have also a range of products which are especially dedicated to this application, and we are making applications for stationary application, including grid support, smart grids, and everything. So all of the factory is located in France, in Le Mans, and in Bordeaux. We have also the legacy office, which is which is making all the BMS design. I mean the hardware, the software of the BMS, which is fully controlled by us, and it's done in-house, so we can make evolution regarding technology and also customer requirements or special adaptation. And around the BMS, we have a full set of tools used for diagnostic, and also cloud storage to follow the fleet of vehicles or the fleet of battery which is deployed in stationary application.
Thank you very much, Philippe, for this presentation. We will now leave the floor to Laurent Meyer, which is going to talk to us about NTech. And if you have any questions, please just feel free to ask them in the chat, and we will ask them later on after Laurent's presentation to the speakers. Thank you again, Philippe.
You're welcome.
Thank you. Can you hear me?
Yes.
Great. Good morning, everyone. So I'm Laurent Meyer, co-founder and chief development officer at NTech Smart Energy. I'm very happy to have the opportunity to introduce you to NTech in a few words first, and then eFactory project Genesis. So NTech is an innovative industrial SME specialized in energy production, storage, and conversion. We provide a turnkey installation, and we are currently 55 employees, active on 5 main activities. So to the next slide. The 2 first one are about PV construction, photovoltaic power plants, medium size for CNI, big size for utility scale, mainly for developers. 2 other activities around storage. First one for grid-tied activities on grid systems to provide grid services for operators. Microgrid systems for mainly abroad and for French islands to hybrid power generation. And then last one, next slide, is innovation activity. Thank you. Innovation activity in order to make solution for from new technologies of storage system and new technologies of production system. For example, we integrate supercapacitors, hydrogen, new marine production technologies, etc. And innovation is a strong differentiator for all the ENTEC activities. So now the eFactory project genesis, we have had the opportunity to be a contact of different markets using energy production, storage, and conversion. And we have seen the greatest interest of these technologies in response to the challenge of energy transition. For instance, this first project is a big storage system in French Guiana. It's for still a few weeks, the biggest battery storage system in France. It's 10 megawatt, 13 megawatt hours. We built it in Quimper in our facilities. And it provides great services to the Guyanese grid, stabilization, frequency regularization, and daily arbitrage, which means more renewables and less conventional power plants, which challenging the response time. Next slide. We also provide grid services and integration of renewable with second life batteries. We commissioned two systems with second life batteries for different constructors, automobile constructors. These systems are operating right now. The next slide, we build several big power plants. We'll go quickly on this one because it's now mature as a component, and different challenges about EV charging. The first kind of system is accelerated charging points, whether DC or AC charging, at least smart charging. We control the power, and even we develop technology bidirectional, which means we can take the energy from the car when the grid needs it the most. And we build also ultra-fast charging station. You can charge 2,000 kilometers each hour of charging. And this leads us to a fact that on these different technologies, there are some components which are redundant, and the strategy of management are sometimes antagonists instead of being additions. So this is why we've modelized what a combination of this technology could bring by mutualizing part of the equipment and globalizing the management strategy to provide more services to the grid and to penetrate more renewables and more new mobilities. So this is a genesis of eFactory. Next slide, please. It's located in our new headquarters in Quimper, France. eFactory is an industrial innovation demonstrator to demonstrate that an economical and technical interest for the combination of all the technology I just showed you, and how to maximize the services to the electrical grid. It's a global investment near 3 million euros with European funds and the support of Britannic Council and support of SMILE as well. So next slide. First, the conception. Of course, is the first thing to do. We have a very sober building. It's a passive house premium building, but we still have a challenging load profile because we made some tests of multi-megawatt systems in which is our activity. So we have a very, very challenging load profile. Then next slide, we decided to put some renewables in order to decarbonize our activity. So more than 400 kilowatt peak of PV power plants, either in a rooftop, sunbreaker, parking shelter, with the new model, the new business model of collective self-consumption, with 3 to 6 neighbors, which we will sell them some solar energy. Then we will install also storage systems of different kinds, different technology of new batteries, NMC, LFP, but also second life batteries, in order to take the maximum, the advantage of each technology, and to have the maximum lifetime of the system. We will provide with this system grid services, and we will maximize the renewable integrations. We have a vehicle fleet which is more and more electrified. So we will install more than 1 megawatt of charging points, one ultra fast for one more time to charge 2,000 kilometers an hour, and smart charging points, bidirectional and singular charging points, because most of the use is you have 4, 5, 6 hours to charge a vehicle, so we don't need to make strong charging at each time. So on the next slide, a resume of all the technology we will install: production, storage, consumption, and new mobility charging system. We will operate the system driven by an energy management system maximizing the grid services and the integration of renewable, and to maximize also the lifetime of the system, which is a challenge we need to face, which is our main challenge also to face. We will share you the results within the next months, and the slide, the current status. You can see a picture of the building under construction. The whole energy system will be in operation current 2021, and please know you will be very welcome to visit our demonstrator with the coordination of SMILE, and I will be happy to answer any question.
Thank you very much, Laurent. Thank you. So we have few minutes for questions. We have already one question in the chat. So it's for you, Philippe Jakubowski. It's from Axel Bodson. 2 questions actually. Do you participate to auctions directly or indirectly organized by Air for Reserve? Is the first question. And then how is working the strategy behind the buying of the batteries? How do you optimize between peak shaving and grid services? And one last question is, what's the profitability of the project, if any? So if you want to read again, that's it.
Yeah. So how we are bidding or we are selling the grid services. So this is done by our partner for this project, which is Enerdigit. So Enerdigit is a company making power regulation on the grid. So power regulation, it consists in getting some customer of the grid turning off their equipment during a peak of consumption. So they know all the mechanism of grid support, grid services, and they are making all the bids, and they are following up all the value sell by the assets. So how is working the strategy behind the bidding of the batteries? How do you optimize between peak shaving and grid services? So this is one of the challenges of the project. And so actually, Enerdigit is developing an EMS, energy management system, which is controlling all the power delivered by the batteries to the grid. And this EMS, we incorporate different strategies to support the grid, either through peak shaving and more traditional grid services. So there are some development, and their plan is to have some experiment on the assets we will set up in our factory, so they can play with the system and try to get different strategy and different approach. What is the probability of the project? So the profitability for the time being, it's balanced. We have a lot of expense in setting up the system, and Laurent is well aware of what is going on. And yeah, so for the project, we have also some fundings from the region to help to set up and to support all the development around the EMS. So I hope it answers to the question.
Okay, thank you very much. We have now a few questions for Laurent. Laurent, what vehicle are you using for bidirectional charging, and what the constructor do you work with for V2G? Laurent, your microphone is off.
Sorry. Good question. For now, there's just one, to our knowledge, a constructor which allows for serial vehicles to provide V2G. It's Nissan, so we work with Nissan, but we also work with some constructor which made some special fleets with V2G possibility. Nearly all of them have made some dedicated fleets. So we work also with Renault, PSA on these subjects.
Okay, thank you. Thank you very much. We don't have any more time for questions, so you can still write down your question in the chat room. And please, if Laurent and Philippe, you are okay to answer directly in the chat room, it would be great, because we have one more question for you, Laurent. And now we are going to give the floor to the cluster TWID. Thank you.
Hello, everybody. I'm Cedric from TWID. So very pleased to be connected with this organization, and very happy to present here for Belgium organization. So we will have two part for the Belgium, so the Wallonia part and the Flanders part afterwards. So I'm starting with Wallonia, and I quickly give you an overview about the regional ecosystem that we have for storage and some examples of ongoing projects. So TWID is a cluster with 140 players, and our job day to day is to support project studies, networking between our members, and to create value for our members. You will discover all the members and the competence that we have in a website called rewallonia.be. In this website, you can discover all the value chain that we have in Wallonia. And for each value chain, you have all the players. There are more than 350 players in the system. And for each player, you can have the different competence that they have. So it's a very easy used website that you can make to make a first link with Belgium and Wallonia especially. And of course, you have direct contacts. And here, for example, you have a player that can play a role for recycling of solar PV, but as well for chemical storage. And for each value chain that they have at least one technology, you can discover what they are doing. We have a dedicated mapping of knowledge for storage application. So you have all the value chain, and for each really spot and dedicated technology for the storage, you can discover what is going on in Wallonia. So I really invite you to discover this website, and all these players that you are seeing on the screen right now are displayed on this website. So you will discover the knowledge and what they are doing right now in the storage application in Wallonia. And as well, it's only in the French part because the website is in English and in French. And in the French part, you can as well discover the projects that we are helping in Wallonia for the R&D in energy. And of course, there is some examples of storage projects. And I will give you right now some example of ongoing project of storage in Wallonia. So our job is to really help to increase the knowledge and the competencies of our members in the value chain and in the technology readiness level. So of course we are working with the R&D centers and the university for the low TRL projects, like for example fuel cell test bench in University of Liège. We have interesting project of new type of lithium-ion batteries applicable like a painting on surface in the different universities. We are working on the solid storage for hydrogen. We are working for thermal energy storage for a sorption reaction. All these projects, we are trying to make some pilots and to improve the readiness level of these technologies. We are helping as well some SMEs and some market players for to increase to put the technologies on the market. I give you 2-3 examples. The first one is NanoSil, one company that has been validated for the EPCA. So the Commission battery value chain, and they have been validated in the very big project of 3 billion euros at the European scale, and they provide for this project the carbon nanotubes for lithium ion. So it's the powder, the magic powder that you can use for the batteries. Another project was phosphate-based cathode materials, and now they have created a company to sell it. It's Preyon BeLife. Other examples is an innovative plug-and-play residential storage solution with CET, COT, Energrid. With batteries, it's always still it's market ready projects like recycling of batteries, and I'm really happy to have discovered the first 2 projects in France, because we see that we have quite the same project across the borders. Some application, I think it's very interesting to see that there are already some market ready project for batteries. The objective 2 weeks ago, we have a presentation, really interesting presentation of Energieville, one R&D centers in Flanders, and they have presented the value staking of the different technologies of batteries. And you see that to have a business case in the storage, you have you have different type of services that you can provide. It could be frequency services, it could be reserve, it could be intraday, imbalance, self-consumption, or peak shaving. And in the future, we see that some technologies on some projects can both use different type of business cases to have a real business cases that is going on in the market. One example is the Centrica project of 18 megawatt of Tesla batteries to make a reserve for the market of electricity, and they are using batteries. And so it's already the case that we have market ready technologies. It's still, we need a lot of technologies and pilot projects in other technologies. And I give you some examples of projects that we are helping in Wallonia. The first is to use the side management and the demand side management to use the flexibility of households and tertiary sectors, and really to take 2 hours and 3 hours of flexibility inside the houses to play as a storage, and at least to make a change of on the consumption, and not to use all the houses at 5 o'clock or 6 o'clock when we come back to our homes. We have to use the charges in terms of hours. So it's to use really the flexibility of the tools that we are using in the houses. Another project quite interesting, because quite similar, that have been presented in France, is the microgrid. Here the project called Miracle is a DC microgrid. So we are using a shared storage unit between 7 SMEs with solar, and they are exchanging in an energy community energy. All this energy community is bring in one single DC, so really direct current microgrid. And so it's the really challenge to avoid AC-DC, DC-AC, AC-DC transformation in the process, and to avoid loss of efficiency. Another very interesting project is PEPS that we have financed last year. It's a mini pumped hydro storage. As you know, Wallonia, we have small, very small mountains, let's say, collines, and we can use it to make some pumping hydro storage. And this objective is to create a modular concept, easy, reproducible, piloted and monitored storage hydro that could be used for a timing of 2 to 4 hours, and typically using mines or different type of sites for big companies like cemetery, for example, and we can use solar PV and storage application. Another very interesting project is Acutherm. Acutherm is to use the thermal cold energy of refrigeration installation, because cold could be used to store energy. And here the concept was to propose a new way of integrated phase change materials to use and to improve this type of technology. And so the objective is to provide peak shaving services with storage of cold. So we can use different type of